Hey, what's up everyone? Welcome to this live stream about implementing generic language support in Passenger. My name is Hongli Lai. I'm CTO at Fusion and the original Passenger developer. Here is what we will cover in this session. First, we will cover why we are adding generic language support. What's the benefit of this? Then we will define the goal of this session, namely the user experience that we are after. Many of you are attending this session not only to witness the implementation, but also to learn something. So to ensure that everyone can follow my coding process, I will explain the passenger architecture before we start coding. I will also explain the implementation plan, the high-level steps that will take us to our goal. If you have any questions or comments, then feel free to enter them in the chat during this session. Note that this session will be recorded and the diagrams will be published. So don't worry if you miss some slides or if you need some time looking at diagrams. You can review them later at your own pace. If you are watching the recording, be sure to share your thoughts in the GitHub discussion thread linked from the video description. Why are we adding generic language support to Passenger, or GLS for short? We think that the application delivery and DevOps experience are too hard, but they shouldn't be. Our goal is to provide an experience that people will love and that will allow teams to move faster. Today, Passenger is in use by more than 650,000 websites around the world. With GLS, we want to bring all the good stuff of Passenger to an even wider audience. For tech leads, an app server that supports all languages means more standardization, which allows better cooperation and less friction between teams. For developers and operators, Passenger helps you focus by automating lots of boring or complex stuff for you. Alright, that sounds nice. But how would that look like? Well, Passenger's main strength is its simplicity. How can we maintain the simplicity while supporting all languages? Here's the user experience that we have come up with. We have been inspired by Heroku. Pretty much all languages and frameworks nowadays have access to a built-in, lightweight HTTP server. Passenger's basic architecture doesn't care what language an application is written in. Passenger just needs to know how to spawn an app and how to communicate with it through HTTP. So our approach is to ask the user for a command string that specifies how the app is to be started on a certain port. And it works as shown here. Passenger automatically replaces the port variable with an actual random free port on the system. But the user and the developer may not be part of the same team or even the same company. If the user is using Passenger to serve a third-party app, then it would be great if the developer can help out by supplying a predefined start command. So we thought that if the app supplies a passenger file.json with a start command inside, then it would be a good idea if Nginx or Apache respects that, making manual configuration unnecessary. Now we will cover Passenger's architecture. Passenger has been architected from the beginning to be flexible. The codebase is split into many components. Each component is designed to be as small as possible and focuses on one thing only. Complex behavior is created by composing multiple components together. There are multiple layers of components. The components in the higher layers build on top of components in the lower layers. The bottom layer implements details and low-level behavior. A large part of this can be reused outside the context of Passenger too. For example, the generic shared code package contains code for memory management, sockets, strings, integer algorithms, crypto, etc. The top layer implements high-level, user-facing business logic. For example, the Apache and Nginx integration and the configuration options that come with them are part of this layer. Command line tools and packaging are part of this layers as well. However, the integration mode package is deliberately kept as small as possible because we want to minimize duplication of effort between the different integration modes. Most of the business logic is actually in the middle layer, which implements high-level business logic that is not directly user-facing. The passenger agent is the biggest package in this layer, and all the integration modes delegate most of the logic to this entity. Within the passenger agent, the core is the entity that contains most business logic. Most of the other entities in the agent only provides helper roles. For example, the watchdog there does nothing more than starting and supervising the core's health, while the spawn-env setuper is only there to aid application spawning by the core. In order to implement GOS, we need to modify these places here. We need to modify the integration modes because that's where the user-facing configuration options are defined. We also need to modify the core because most of the heavy lifting is done there. If we dive into the passenger agent, then its internal architecture looks like this. We're going to zoom into the core because we only need to consider that. The core itself is also architected according to the principle of having lots of small components that are then composed together. As you can see here, the core consists of 3 layers. The top layer only interfaces with the middle layer called the application pool, and the middle layer only interfaces with the bottom layer. The top layer's main component is the controller. This is passenger's main request handling server. All passenger-handled requests pass through this component. It parses the request, selects an application process to route a request to, then forwards the request there and writes the app's response back. The controller also performs things such as request body buffering and response caching. The main application process management and load balancing logic are, however, the responsibility of the application pool subsystem. The controller basically asks application pool, give me the address of an app process to forward to, I don't care how you do it. The application pool then does just that, possibly spawning a new process if it thinks that there aren't enough. The application pool keeps track of which processes exist, as well as load balancing statistics. There are also background operations, such as shutting down processes that have been idle for too long. The act of reliably spawning processes turns out to be pretty complicated as well. So all the spawning logic exists in yet another subsystem, spawning kit. This subsystem is not used directly by the controller, and the application pool uses that instead. The application pool tells spawning kit something like, I need another application process at this location with this spawning strategy, and it needs to initialize with this log level. Then spawning kit replies with the process details, such as the PID and the socket address on which the process listens. Now we just covered passenger's structural architecture. Let's look at the interactions between the different components within a single request lifecycle. A request normally begins with inside the web server, so that's either Apache or Nginx. If it is a static file request, then they will just handle it directly. But if Apache or Nginx think that the request should be handled by passenger, then they will forward that request to the controller. Note that passenger standalone, when configured to use the Nginx engine, which is the default, is not a web server in itself. Under the hood, it is powered by passenger and Nginx. And when the passenger standalone is configured to use the built-in engine, then it just skips Nginx so that requests are directly received by the controller. So no matter what, all requests go through the controller. And here you see the controller performing the interaction with the application pool as I described before. It asks the application pool, give me the address of a process I can forward the request to. Then depending on whether there are enough processes around, the application pool will either immediately return the requested information or spawn a new process through spawning kit first. The controller then proceeds to forward the request to the application process. So that was Passenger Architecture 101. Again, the diagrams will be published. So if you need to look at them again at your own pace, feel free to do so. Now that you know how Passenger works, let's go over the detailed implementation plan. Let me start with a piece of good news. We already laid a good foundation for GLS a while ago, so there is a lot of heavy lifting stuff that we don't have to implement during this session. In Passenger 5.3.0, we rewrote Spawning Kit. We overhauled the spawning protocol and we introduced support for a so-called generic spawn flow. What does that mean? Well, in order to understand what it is, let us look at the normal spawning flow, that is the one used for spawning Ruby, Python, and Node.js apps. These apps are so-called auto-supported apps because Passenger automatically supports them. It begins with the application pool requesting Spawning Kit to spawn a process. Spawning Kit then performs some preparation work and it creates a temp there called the work directory. Then it dumps the configuration for spawning into a JSON file in that directory. Next, Spawning Kit executes the so-called language wrapper. This is a script which is part of Passenger. We have a different script for each language. For example, the language wrapper script for Ruby is called regloader.rb. So one thing to understand is that in a normal spawning flow, Passenger does not execute the application directly. Instead, the wrapper is responsible for loading the app inside the same process. On Ruby, this is implemented with eval. On Node.js, it is implemented with require. The wrapper also performs a bunch of other things, such as setting up stats collection and setting up an internal server. Finally, the wrapper dumps its server address to a file in the work there, and then it sends a signal back to Spawning Kit through a pipe in the work directory. Spawning Kit then cleans up the work directory and returns the information to the caller. So that was the normal flow for auto-supported apps. What about the generic flow? Again, the generic flow was introduced in 5.3.0, but it is not exposed to users. So it's just an internal mechanism in Spawning Kit sitting there and being unutilized. And it works like this. The flow is similar to the auto-supported flow, but with a twist. In the preparation phase, Spawning Kit looks for a free port on the system. Spawning Kit does not execute a language wrapper. Instead, it executes the application directly using a user-supplied command string. The port variable in the command string is substituted with the actual port number found earlier. The app will do what it normally does. Meanwhile, Spawning Kit waits until that port becomes in use. And when the app is done initializing and is listening on that port, Spawning Kit will take that to mean that the app is ready and then return to the caller. So Spawning Kit already supports all the heavy lifting mechanisms necessary to implement generic language support. The goal of this session is to build all the higher level mechanisms needed to activate the generic spawn flow when appropriate. And here is our plan. In the integration mode frontend, we're going to add the necessary user configuration options. Inside the web server modules, we're going to determine whether that request is associated with an auto-supported or generic app. And in case of the latter, we're going to determine what the start command is. We then pass all that information to the core controller. In the controller, we're going to tell application pool whether we're dealing with an auto-supported or generic app and the associated start command. We usually take this information from what the web server passed us. But in case of Passenger standalone with built-in engine, there is no web server. So we need to figure this information out locally in the same way the web server did. Next, we're going to modify the application pool to tell Spawning Kit whether to use the auto-supported spawn flow or the generic spawn flow, along with the associated start command. And various data structures in the application pool also need to be updated in order to accommodate all this new information. Finally, we need to ensure that generic processes are properly cleaned up. Process cleanup with auto-supported apps is implemented by closing their standard input. The language wrapper automatically watches for this event and performs a clean shutdown. But we cannot assume that generic apps will do this, so we need to explicitly terminate them with a signal. And here's the configuration to activate the different Spawning Kit flows. For the generic flow, we just need to set the generic app field of the configuration object to true, and to set the app start command field to the user provided value. Most of the other config in the object then becomes irrelevant in the generic flow. So now that we have a plan, let's start coding. And again, if you have comments, just write them in the chat or post it on GitHub. So the first thing we're going to do is to add a configuration option to the Apache integration mode. And this is done by adding an entry to Apache 2 config options.rb. So if you have ever written an Apache module before, then you know that you have to modify all sorts of C structs and adding function pointers in there to set some fields in some more C structures. Well, that's a lot of boilerplate code. And we in the passenger team got tired of doing that sort of stuff, so we introduced an auto-generation system that will generate all that boilerplate C code for you. And the only thing you have to do is to add an entry in this file, which is a Ruby file that defines an array of hashes that define all the options. So let's say the command that we want to add, or the configuration option that we want to add, is called passenger app start command. So let's find a good place to put that. So the passenger code base has a difference between global configuration options that you can only set once, and per application configuration options, which is things like passenger Ruby or passenger app type, passenger start file min instances, that sort of stuff. Yeah, so let's add it here, and we say this is passenger app start command type. It accepts a string value. The description for this is command string for starting the application. And we set, I think it would be a good idea to set the header to nil here. And I will explain why in a minute. But let's try to compile this. Let's see, new terminal. And we invoke the compilation system or the build system in Passenger, which is built on Rake, or the Ruby version of Make, so to say. We use the Drake command here, which is a fork of the Rake command, which supports running multiple commands in parallel. So that's how we can run multiple compilers, one for each CPU core, in order to speed up the compilation process. And yeah, let's not do Nginx. Let's say, yeah, I definitely want to include the to make sure that the build environment can find the include files for my Apache installation. Okay, let's go. Let's say that we want to compile the Apache 2 module. And yeah, as you can see here, it's running all sorts of commands to compile. This will take a while. Actually, I'm recording right now, which takes lots of CPU time. Okay, let me reduce the number of cores that it uses. Otherwise, we might get frame skipping or something in recording. So it's compiling all sorts of C++ files. Well, actually, while it's compiling, it would be a good time to explain why I added this header nil thing. So in the architecture diagram, you already saw that passenger, the web server forwards requests to the passenger core controller, and it does that through HTTP headers. So there are some special headers which are reserved for passenger internal use that will contain the configuration associated with the current request. But I mean, normally for most configuration, we will want to pass that configuration value to the core controller so that it knows what to do with it. But the passenger app start command is a special case because in the user experience definition, we said that we don't only want to pass the configuration from the config file directly, but if there is a passenger file.json and there is an app start command in there, then even passenger for Apache or passenger for Nginx should also detect the content of passenger file.json and maybe use that instead. So that's why I set the header here to nil, which tells the auto generation system not to emit any code that automatically forwards the value in the configuration struct to the passenger core controller. Instead, we will write that code ourselves in part based on what we have detected in passenger file.json. Okay, so the compilation is done, and there's okay. So this is what I wanted to show you. These files have been automatically generated or updated because I updated this config options.rb. And if I run a git diff, then you can see what's different. Okay, so there is a config file here which has all the Apache module commands, configuration commands elements. So it generated this code here, which is normal for an Apache module. It also generated a setter function called here. And what the setter function does is it assigns a field in the config struct to its value, but it also sets a bunch of other boilerplatey stuff that we need. And it automatically generated the code for initializing the default value. There is code for there's all sort of other useful boilerplate code, and you just don't want to write all these yourself. It just makes no sense. By the way, I've been told by a coworker that it's kind of weird that I'm using a light theme because most developers apparently use a dark theme. I said, what? Is that really so? I find dark themes really unreadable, but maybe it will help the viewers here if I change my color theme to dark. Let's see. Well, let's just pick Dark Visual Studio. Yeah, there we go. And I guess maybe it would be a good idea to further increase the font size just so that you guys can read this better. Okay, so we added a configuration option for the Apache integration mode. Then the next step should be to let's see, we should modify the module to auto detect whether the application is an auto supported app or a generic app. And the place to do that is in the directory mapper. So the directory mapper file in the Apache module, it is responsible for given given a request in Apache, it tries to determine which application does that belong to, what kind of application is it, or is this not an application, not a passenger handled application at all, and the request should just be handled by Apache. So let's see. Yeah, let's hide the console for now. There is, oh yeah, okay, we need to have the auto detect function here. What should I do? Oh yeah, I think we need to update this one. So what it says here is that this function here creates an app type detector object, and that is the class that is responsible for auto detecting the properties of the application. And this class is also used inside the Nginx module. Let's see. Okay, so let's try this. If app start command is set, then it means the configuration specified that it is either a generic app, no, that it is a generic app. So we should check whether this is not empty. Okay, so in the previous step, I added the app start command option, and the auto-generated code automatically added a field to the configuration object that is related to this module. And I should actually show you what was added. So the server config here is related to the global configuration, while the dir config here is related to the Apache per request configuration for this module. And this is the auto-generated struct. What was it called again? App start command. Okay, this line was added, but you notice that in directory mapper, we do not access that field directly. Instead, we use a getter. So the getter was actually also automatically created. Get start command. Okay, there's something wrong with IntelliSense. Let me just use a normal find. So why do we do this? It's because depending on what kind of application, what kind of configuration type this is, the getter might do something else. Or depending on whether a default value is specified, the getter might return a default value. So it's always a good idea in our Apache module code to use the getter instead of the fields directly. Let's see. If it is set, then we should say that the app root is this. Yeah, so if it is a generic application, then we shouldn't use the app type. I worded that wrongly. If the app start command option is set, then we can just assume that the application is a generic application because the user specified so. And so we directly set, we're directly going to return this as the return value instead of invoking the app type detector, because there is no need for doing any kind of auto detection based on the content of the file system. So we should, let's see, what else do I need to do? Yeah, okay, let's reconcile the original if statement here by adding an else. And yeah, what is actually happening here? Let me add comment. If neither app start command nor app type is set, then we should auto detect what kind of app this is. Let's see there. Yeah, I should also add a comment here. If app start command is not set, but app type is, as well as the required app root, then verify whether the given app type value is supported and resolve aliases. Okay, so these comments should accurately describe what's going on here. Okay, so far the directory mapper that performs the auto detection, but there are a couple of more places that we need to edit. Is the IntelliSense still not done? No, still updating. I have no idea why it's doing this. Let's see. Where do we use the directory mapper? We use it here. Okay. Yeah, the prepare. So there's a hooks.cpp file in the Apache module. There's a prepare request function here, and this function is called before any request to check whether the Apache module for passenger should handle this request. And inside this function, it makes use of directory mapper. So depending on whether the mapper says that it is a passenger handled application or not, we should return something to Apache telling it whether this module will handle this request or not. Let's see. And there's a special case here, I believe, that needs to be handled. Okay, so if the get detector, so the mapper invokes an auto detector, and if the result of that detector is no, then we should then the passenger module should not handle this request. But there's a special case here, namely that if the get app start command option is set, then we're not going to invoke the auto detector at all. So in that case, we should also have passenger not handle this request. Okay, now that we have that, okay, so we figured out whether passenger should handle this, and if so, what kind of application it is, but we also need to pass the correct information to the core controller. And there's a function here which does that. So this information is passed to the core controller through HTTP headers, through special HTTP headers that the controller will read. Yeah, so this is the function. It is called construct request headers, and this means the request to be sent to the core controller. And yeah, you can see I'm really constructing an HTTP request buffer here. Let's see. Yeah, so normally we tell the controller what kind of application type this is based on the auto detector result, but we don't always invoke the auto detector, and so we need to add a few if statements here. Let's see, if get app start command dot empty not empty, so the config is set, then yeah, in case you're wondering, yes, the exclamation mark and the tilde here, this is allowed as part of the HTTP header standard, but there's code in Passenger that ensures that only the web server module is allowed to send headers beginning with this prefix. Otherwise, it will reject them. So so clients cannot spoof these headers. App start comments. Okay, that was the name for the header. What should be the value? Oh, yeah, of course, the config option itself. Okay, in case you guys are wondering what the add header here is and what the p static string here is, result is a string object. An add header is a function that merely appends this together with an HTTP header semicolon and the value to this string, so that I don't have to do as much typing. One important object that we use throughout the passenger code base is the static string class. So let me show you. A static string is nothing more than just a lightweight container containing a C string and its length. So in contrast to the C++ standard library string type, which always dynamically allocates memory, which can be slow, we try to use the static string type, our own static string type, where possible, in order to avoid too many dynamic memory allocations. So the entire passenger code base makes as much use as possible of a so-called zero copy architecture, which means that we don't copy string data around unless it is absolutely necessary, because copying is expensive. Or at least dynamic memory allocation, that especially is expensive, and we want to avoid that where possible. And the p static string here is a C macro that allows me to construct a static string object easily from a statically defined string in the code. Because usually to compute the length of a string, you need to call the C string length function, which during runtime will try to scan the entire string looking for the null byte and then returning a length for that. But if it is a static string in the code, then we already know the length. So we do not need to use string length, and we can use size of in order to calculate the static size, which avoids a lot of overhead. Okay, so let me continue. If mapper.getDetector results, let me first type this and then explain what I'm thinking. Let's see. Yeah, so this was the original code. We added a check here for whether the start command option is set. But actually, the UX definition said that the Apache and Nginx module should also check whether there is a passenger file.json and whether there is an app start command specified in passenger file.json. And I'm thinking that this would be the right way to figure out whether that is the case. So the auto detector class currently only returns what kind of auto supported app this is. So this is encoded into the app type header, and the information comes from the wrapper registry entry. So the wrapper registry is a database that contains all the language wrappers that Passenger supports. But in case there is a passenger file.json with an app start command in it, then the application is actually not an auto-supported app, but a generic app. And yet the configuration was not set in the Apache configuration. And so there needs to be an extra if here. Yeah, I'm thinking that the best way to differentiate between those two possibilities, so between the possibility of the auto detector has detected this as an auto-supported app, or the auto detector has detected that this is a generic app based on passenger file.json, we should do that based on whether it sets this to no or not, because if it is not no, then we should return this instead. And this is a field that in the detector results struct that does not exist yet, so we need to add that. Okay, so now's a good time to modify the app type detector. Let me close this and let me close this. Okay, so the app type detector is currently part of the C++ of the shared passenger C++ code. Okay, so this is the detector class in app type detector /detector.h. Okay, this is the result struct, and there is a function here which is called by directory mapper. Let's see, what does directory mapper call again? It calls either check app root or check document root, depending on what kind of configuration is set. But check document root actually calls check app root under the hood after performing all kinds of other calculations. So the only place we need to modify is the check app root function, as well as the result struct. But let's modify the result struct first, because right now the result consists only of the auto-detected wrapper registry entry that is related to the application. But in case passenger file.json exists and contains app start command, then we want to return the app start command in passenger file.json as well. I mean, either this is going to be not no, or this is going to be not empty. Yeah, as for whether the entire result should be considered no, I guess it should be considered no if both things are no or empty. So app start command.empty. All right, that was the result struct. Let's head back to the check app root function. What should we do here? Yeah, so what the function does is it merely iterates through the entire wrapper registry database, and then for each one checks whether the file related to that wrapper registry entry can be found in the application root. But if we want to auto-detect what's in passenger file.json, then we need to invoke something totally different. So let's say that, let's type some pseudocode here. Let's say that we want to auto-detect what's in passenger file.json, and then that returns a result. And if that result is not no, then okay, I should actually not call this result to avoid confusion with the app type detector result object. So let's call this x for now. If x is not no, then we want to construct an app type detector result object, and then return.result, and we want to set the results app start command to whatever can be found in X. Something like this. Okay, we need better naming for this, so let's call this let's call this app local config, and let's call the class itself or the struct itself also app local config. And this function, let's call it parse app local config file. And it needs an app root because it needs to know where passenger file.json is. And if app local config.app start command is not empty, then we do this. Okay. Let's see, am I missing something? No, I don't think so. Yeah, we will want to, let's try to implement this right now. Let's create a new file here, call it let's call it app local config file utils.h. Let's include a C++ header card here. Passenger app local config file utils.h. Yeah, so for those who are not familiar with C++, the include statement in C++ is similar to JavaScript's require or Ruby's require or Java's import and that sort of thing. But the weird thing about C++ is that this works through the preprocessor. So what an include actually does is it takes the content of a header file and then directly pastes it into your source. So if you have multiple, so if you try to include a header file and that header file includes, let's say, a header file named foo, and then you also include header file foo in your original file, then foo is included twice, and that's not good because then you have duplicate definitions. So the usual way to fix that is by defining a macro as the first thing in your header file, and also to put the entire source of your header file inside if def guard. So only if this thing here has not been defined before, meaning that this entire file has not been included before, then do we actually output something. Yeah, it's a really weird thing about C++, and they're getting rid of that with the C++ module system, but that's still at least several years away. So for now, I just do this as mechanical boilerplate code that I always put in all my code. Okay, and all code in passenger has the namespace passenger. Let's see, we want to define the struct app local config, and it consists of a app start command. We want to define the function parse app local config file, and it takes an app root as argument. So this function takes an app root as argument and returns an app local config object. Okay, let's first take the path of the passenger.json file, which consists of app root plus passenger file.json. What should we do? We should open the file. With read-only flag. Yeah, you know, there's a security concern here, because so this code here is called from the Apache module, which on most systems runs as root. And if a process is running as root, and it tries, then it is especially vulnerable to symlink attacks. So what I mean by that is that if a root process is instructed to read an arbitrary file on the file system, and a non-root user has control over that path, or over parts of that path, then then that non-root user can change that path into a symlink that points to an arbitrary file on the file system. So what happens then is that your root process will read an arbitrary file. That may or may not be problematic, depending on what you do with it. For example, if you are a web server and you read that file and then you print it to the web server response, then a local non-root user can abuse that in order to read an arbitrary file on the system through the web server. So that's not good. We need to think carefully about what we're trying to do here. You know what? I think we're actually safe here, because the only thing we're trying to do here is to return the content of the appstart command, which is not really a secret. I mean, if the appstart command contains credentials, well, you shouldn't put that in the appstart command anyway, and you should put that in an environment variable. So as long as we only return this and we do not print any of the other content, for example, to a log file or otherwise leak it out to outside this function, then I think it should be safe. But there's another thing here that we need to worry about, and that is so-called so users can also perform a denial of service attack by having a root process read from a FIFO file, a pipe file. And the peculiar thing about pipe files, which are created with the mk FIFO command from your shell, is that if you try to open it, but there is no, if you open a FIFO file from the one side, then there needs to be a corresponding process opening it from the other side. So then one side reads and the other side writes. But if a malicious normal user created a FIFO file without also opening another process to write to that FIFO, and passenger tries to open that file as read, then that will result in the open blocking forever. So we should open the file as with a non-block flag in order to prevent that kind of attacks. By the way, these attacks are we have documented that in one of the files that we use, namely, oops. Let's see. There's a support library here in the passenger code base called file tools, and there is a file manip.h, which contains all sorts of files for manipulating or reading files. And there's a function here called save read file, which documents all the attacks that I have talked about just then, and it tries to mitigate these attacks. But this mitigation requires specific circumstances that are not applicable to this function that we're writing. So we need to mitigate these attacks ourselves through other manners. So if you're a passenger contributor, remember that if you perform any kinds of file operations from the C++ code base, be sure to use the save read file function from the file tools package. Let me write some comments here to make sure that we know what we're doing. Reading from passenger file.json from a root process is unsafe because of symlink attacks and other kinds of attacks. See the comments for save read file. We are unable to use save read file here because we do not control the safety of the directories leading up to app root. Yeah, so save read file can only be used if we are able to control the safety of the directories leading up to the directory from which we're trying to read. What we can do here is preventing the contents of an arbitrary file read from leaking out. Therefore, our result struct only contains a limited number of fields that are known not to contain sensitive information. We also don't propagate JSON parsing error messages which may contain the content. Okay, so now we've defined what we want to do in this function. Let's check for errors. If we are unable to open the file, then it will return a file descriptor of -1. And if the error is no-end, which is an error code returned by the operating system, then we return the empty app logo config object. So it should not be considered an error as far as this function is concerned if passenger file.json does not exist. However, if we encounter any other kind of error, then we should throw a file system exception. Error opening path for reading with the error code and the path. Okay, so in case you're wondering, why do I assign errno to a temp variable here instead of using it here directly? It's because errno is a global variable that can be overwritten by many different functions. And what we're doing here is here we are constructing a C++ string object which under the hood may call the memory allocator or call other kinds of complex functions which may overwrite the errno value. So if you intend on doing anything complex, then you should put the errno in a temp variable so that you don't lose it. Okay, we're making use of all kinds of functions here and all kinds of classes. We should add a bunch of includes. So open is in fcntl.h. We're using static string. We're using the C string object. Okay, fcntl.h. Thank you, Visual Studio. And the C++ string class is in the std namespace. Oh yeah, we're using erno. So let's say include cerno error number. And file system exception is in exceptions.h. Okay. Okay, next we should try to read the entire file. And there's a function here in file tools called readAll. It reads from this fd. This requires, okay, well, let's include that first. File tools filemanit.h. Okay, so for security reasons, the readAll function requires a size limit, so that because it slurps all file content into memory. But if the file is, let's say, 60 gigabytes, then you will crash the system. And so for security reasons, let's say that the maximum number of bytes that we try to read is at most 512 kilobyte. I think that's reasonable for passenger file.json. And what it returns is a pair of, so a pair is something like a tuple containing both a string and a boolean. Well, if you go to the definition of read file, oh man, IntelliSense is not working again. No, not read file, read all. Oh, was I wrong? It's not in this file. Okay, it's in IO tools, in IO utils. Okay, IO tools, IO utils. .h, and you can see that it returns a pair of content COF, and this is the content, and this indicates whether the entire file has been read or not. Yeah, it can go wrong. Reading an error can occur, and if an error occurs, then we want to translate that to a relevant exception. So let's say we do this, and reach all throws a system exception, which means an arbitrary operating system level exception. So something that would set the error number global variable. But in case we catch this exception, we want to turn that into a file system exception, and a file system exception is the same as a system exception. It's a subclass, but it also includes information about the path that triggered this exception. So let's see, error reading from path e.code path. Okay, this seems fine. Oh yeah, there's also one thing, and that is if we leave this function, then we want to ensure that the file descriptor here is closed. And the best way to do that is using an FD guard. The FD guard is a resource acquisition. You know what? I don't even know how to really pronounce that. It's a mouthful. So the term in C++ is RAII. Resource acquisition is initialization. And this is a resource management pattern in C++. If you're writing JavaScript or Java or Ruby or something, then you know that if you want to ensure that a function cleans up a resource before it returns, then you try to use something like try finally, or in Ruby, begin ensure. In C++, however, it is customary to use this pattern, which means that you create an object here, and the sole purpose of that object is to clean up something when it is destroyed. So when in C++ you leave a certain scope, and a scope is defined by brackets, then if there are any objects defined in that scope, then their destructors will be called. So the fdguard is a class that accepts a file descriptor, and when this object is destroyed, then it will call the operating system close system call in order to close the file system. So you could say that this is similar to the defer the defer function in Go. And the fdguard comes from scopeguard.h. So we need to include that, util scopeguard.h. Okay. And this works even if this function is left because of an exception. So if this exception is thrown here, then the fdguard's destructor will run and the file descriptor will be closed. But in any case, after we have read from the file, we want to close the file descriptor immediately. So we can say fdguard.run now. Okay, now we have the content as a string. It's time to parse it as JSON. We use the JSON CPP library here. JSON CPP is a third-party library that we use, which is a really good library, by the way. And we say, let's see, the reader is a class that parses JSON into objects. So let's say we try to parse it, and if it doesn't work, then we need to do something with the error. Okay, we parse this string into the following JSON value object. Excuse me. Yeah, and there's something special that we need to do if we are root, because then we need to especially mind the security concerns. We don't want to leak out the error message. So let's say we're not root. Let's do that first. Error parsing path reader.get formatted. Yeah, so they have two functions in here that can return the error messages, but in an earlier version they had a typo in here with one T, and they deprecated this function now, so we shouldn't use that, and we should use the correct one instead. And if we are root, then we say, let's just copy that. Error messages suppressed for security reasons. Let's we're getting get EUID here, but where does that come from? What? I don't have man pages anymore? No way. I upgraded to High Sierra recently, and now my man pages are gone. Okay, I need to figure that out later. I think it's in unisd.h. And well, now that we have parsed the JSON file, we do not need the string anymore. So let's truncate that string in order to save memory now. Content.first.resize 0. Okay, now we can do something with the parsed JSON. Let's construct a result object and we want to return it. We will want to validate the parsed JSON if the JSON object is not, or actually if the JSON value is not a JSON object, then we throw a runtime exception. And we say config file path is not valid. Top level JSON object expected, and this should be on a new line. If the config has an app start command, then we need to do something with it. If app start command is string, okay, if it is not a string, then we need to throw a runtime exception again. Config file path is not valid. Key app start command must be a string. Result.app start command is config app start command.s string. Oh, app local config. Yeah. Okay, I think this will do. IntelliSense still working for some reason. Okay, so that covered the entire Apache module part. Okay, actually not entirely. I remember that in the app type, app type detector, we make use of this. Oh, and there's even an X here. So app local config, and we need to include this file. Let's say app local config file utils.h. Okay. Yeah, IntelliSense is still updating. Let's ignore the red lines here for now. I think this should work. And the good thing is that we have not only modified the Apache module, but we have also written shared code that we can reuse in the Nginx module as well. Okay, so let's go to the Nginx module this time, and let's close all our files to avoid confusion. In Nginx, we should add a similar configuration option, and this option 2 is specified in Nginx config options.rb, and here we have a similar auto code generation system as well. So let's add a per application config option, and we say that the name is passenger app start command, and the scope is application. So it's a per application option. Type string, and here we also set header nil for the same reason as in the Apache module. Let's open a terminal, and then we say let's compile the Nginx parts and have it also generate all the files. Okay, we're not interested in compiling everything else. We just want the the auto-generated files to update, and we'll compile everything else later when we're done writing the code. So writing an Nginx module is very similar to writing an Apache module. In fact, I think the Nginx codebase has been inspired by the Apache codebase because Nginx came later and they learned from Apache, but I have to say that the Nginx codebase overall is more consistent and also more efficient. It doesn't try to allocate dynamic memory all over the place like Apache does, and all the strings in Nginx, they have a length field instead of in Apache where all the strings are null terminated, and to find out the length of a string you have to scan the string for the null byte. So those are some of the reasons why Nginx is considered faster than Apache. Let's see. We need to do a similar thing in Nginx, namely we need to figure out whether an application is auto-supported or generic. And the place to do that is in the content handler. So when you specify passenger enabled on, then what that will do is that Nginx will make sure that all requests for which that config option is set, it will route those requests to the passenger content handler function inside the passenger module in Apache. So we're looking for a specific place here, similar to the place in the Apache directory mapper. Okay, I believe it is here because here we create an app type detector object, except we're so Nginx module code has to be written in C, not C++. So this is using the C wrappers for the app type detector C++ class, and we need to do something similar here. If app type command is set, then it means the config specified that it is a generic app, so that we do not invoke the app type detector if in Nginx the config object is called slcf, and inside the command struct there is an no, not the command struct. So the configuration struct in the Nginx module has a manually written part and an auto-generated part, and the auto-generated part is part of the auto-generated field. So this field here is auto-generated. If that is not set, let me write something before I explain what's going on. Yeah. Okay, so this is the old code here that is only invoked if we want to have the old code that invokes the app type detector to only be invoked if the app start command option is not set. So if neither app start command nor app type are set, then auto detect what kind of app this is. And the auto detection result can either say this is an auto supported app or a generic app. What else? So if the app type detector result is no, then we do that. But if it is not no, and the app start command option is not set, actually this is the wrong place. Yeah, here. Then if app start command is not set but app type is, then verify whether the given app type value is supported and resolve aliases. So we put all the old code inside the checks that checks whether the app start command option is not set, because if it is set, then we don't want all the we don't want the app type detector to be invoked at all. Yeah, so if this is set, then we just want the passenger module to assume that it is a generic app, and so it should handle the request. Oh, I did something wrong. Let's go back. Okay. Yeah, so in Nginx, what a function should do is returning either Nginx declined if it is not, if it thinks that this module should not handle the request, or it should just go ahead and handle the request. So in the module, in the passenger module, there is another function for setting up the headers to be sent to the core controller, and that is called yeah, there are two functions actually. There's a function prepare request buffer construction. And there's a part here that does something with the wrapper registry entry and the app type detector result, and we need to modify that. Okay, so we need to get rid of that and change that into this. SLCF, auto-generated, if the app start command option is set, then we need to do something, and otherwise we need to do something else. The config specified that this is a generic app, so we should say that we should set this. So as you can see, there is a state object here. And what does that state do? Well, the prepare request buffer construction function prepares a state object so that there's another function down the line that actually constructs the buffer, but this prepare function prepares all kinds of information that the construction function later needs. And one of those, one of the things that it needs to prepare is to figure out what kind of application this is. So in case that this is a generic app, we just say app type is no, because it makes no sense. And instead we said app start command to what is in the configuration file. And this field does not exist yet, so later we will need to add that. Oh yeah, in case of the else, okay, let's go ahead and move that to here. So if the app start command option is not set, then we will want to use the app type detector auto detection result. But the result can either say that it has detected an auto supported app, which is what we are checking here. Wrapper registry entry is not null. This is an auto supported app. Okay, let's move that here. Okay, this is a very long line. Okay, let's do this. But we should also set the app start command state field to null. In both C and C++, if you allocate a struct, then all its fields by default are uninitialized, so they can contain random garbage data from memory, and you should explicitly set them to something. Otherwise, it's just garbage. What's in there, they can cause all sorts of trouble down the line. So, well, the else, this is a generic app. We say app type data is null, so there is no app type. And app start command is we try to obtain this from the app type detector result. And the API, the C API for doing that is psg app type detector result get app start command. I think this does not exist yet, so we need to introduce that. Okay, so Nginx has its own static string type, which is called ngx lower score string. So we need to convert whatever this returns into the Nginx format. And I'm guessing that this function, which has not been written yet, it will accept a detector result object, and it also needs some kind of way to return the length. So let's store the length inside the Nginx string object. Oh, it's len. Okay. Yeah, let's modify the app type detector C bindings and add this function. Okay, so these are the functions for the app type detector result object. We're adding our now. It returns a const pointer to a C string type detector result get app start command app type detector, and this function takes an app type detector results object, and it takes a pointer to an integer variable. And for those of you who don't know, a pointer in C or C++ is similar to a reference. in Rust, I guess. No, Java does not have that concept. Ruby also does not have that concept. JavaScript also does not have that concept. So what we're doing here is we tell this function, hey, if you have a string, store it inside this variable here, and I'm giving you the address of that variable, and then the function will write to that address. Okay, that was the function definition. Let's actually implement the function now. Okay, we need to turn the C binding handle to a C++ object. And we want to return the appstart command, but that is a C++ string, so we cannot return that directly. Instead, we return the C string data inside the C++ string, and if the length argument is given and it is not set to null, then we dereference the length argument. So we write to the variable that this pointer points to. So we set that to the length of the C++ string. Okay. Now that we have modified the preparation function, we should modify the buffer construction function itself. And this is called construct request buffer. It is very similar to the header construction function you saw in the Apache module. So as you can see, it constructs an HTTP request buffer. The part that constructs app type will need to be modified because we don't always want to pass app type. It depends on whether the preparation function thinks that we should do it or not. So if the app type field is a non-empty string, then we do whatever we used to do, and otherwise we will want to pass the passenger app start command header to the core controller instead. Okay. Now we go back to the state struct, because where was the state struct again? Oh yeah, here. App start command, okay. Yeah, there's one thing I missed. I think, yeah, I'm using SLCF here, the config object, but this function does not have access to that, so I need to add it as an additional parameter. And then I need to modify the colors as well. Okay, there's only one color. SLCF. Okay, there we go. So actually there is a typo here. in the Nginx module, I said state app store command, but it's supposed to be app start command. I fixed the Visual Studio IntelliSense issue, so now things should be a lot faster with the IntelliSense. Okay, we're done with the Nginx module. Now let's work on Passenger standalone. We need to add a configuration file there. So let's do that. It's in standalone config options list.rb. Now the Passenger standalone front end is entirely written in Ruby, so there is no code auto generation involved. However, things are also a bit more there's a lot of boilerplate stuff that we haven't gotten rid of on the Passenger standalone side, so we need to do a bit more work here. And I see that something here in the code results in an error with the syntax highlighting, but let's ignore that for now. Maybe we can fix that. Yeah, okay, we just say that this is a regex. Let's see, name, app start command, type desk is command, desk is force the app to be started through this command. So Passenger standalone is not a web server in itself, but it is merely a wrapper for either starting Passenger plus Nginx, or for starting the Passenger agent with the Passenger core directly. So that's why in this config there is no equivalent to the header thing. And when Passenger standalone is using the Nginx engine, then under the hood, it actually generates an Nginx configuration file. So we need to modify the configuration template, which is in resources, template, config, not config, standalone, server.erb. So server.erb is the template that generates a single server block in the Nginx configuration file. Let's see. Let's add it here. Given a app start command option in the Passenger standalone configuration, it outputs an app start command directive in the auto-generated Nginx config file. Okay, so that took care of the Nginx engine. There is also the built-in engine. And the built-in engine works very differently. Because it starts the Passenger agent under the hood, we need to pass the configuration to Passenger agent, and that happens through command line options. So we go to Passenger standalone, start command, built-in engine.rb. There's code down here in build daemon controller options, and daemon controller is the library that Passenger standalone uses for starting background daemons, such as Passenger agent. And here you see all the command line flags that it tries to pass that. Yeah, on the startup file would be a good place. At bottom commands, app start command, minus app start command. Okay, so we passed the option, we passed the command line option to Passenger agent, but the Passenger agent has to parse that command line option somehow. So we need to modify the option parser. And so each entity in the passenger agent, whether that's the watchdog or the core or the other thing, they all have their own option parser. But in this case, because the core is going to use it, we're going to modify the core's option parser. Let's add a help string for now. So we are inside the core usage function, which prints the help message. -- app start command. And here's another print. The command string with which to start the app. We need to make sure that the strings we print out here do not exceed 80 characters, so that they do not wrap around in a default terminal size. And we say that this is actually for the single app mode only. The single app mode is a mode in which you start the passenger core when it is dealing with passenger standalone plus built-in engine. Normally, it is started in multi-app mode, because when the passenger core is running, then Nginx or Apache can be serving multiple different applications. So multi-app mode is the default, but when using passenger standalone with a built-in engine, then it tells the passenger core to switch to single app mode. And only in that mode do we accept this, because otherwise it makes no sense to accept this. Okay, so this is the help message, and we need to modify the actual option parser as well. Startup file here. Okay, this is the function parse core option, and what this function does is every time the caller iterates, no, I should rephrase that. When the caller iterates through all the command line arguments, and then for each argument it tries to call the parser. And here we say that if the argument that we are parsing right now equals app start command, is this right? Yeah, okay. Then we do something with the value that is associated with that. And we do that by setting a hash table to that value. We set the hash table entry single app mode app start command, and we increment the iteration integer with 2, because we handled both the name of the command line argument as well as the value. Okay, that handled option parsing. There is another place in passenger standalone that we should modify, and that is the app finder. The app finder is a class in passenger standalone that checks whether, given a specific directory, whether it contains a passenger served app. So and it needs to return either true or false. And here we say that, well, if app start command is given, then we just assume that it is a passenger handled application, because why else would the user set this configuration option? Okay, and this concludes passenger standalone. We haven't fully modified the passenger core's single app mode yet, but we'll do that later because it's a little bit complicated. Okay, let's take a look at the plan again. So we did the first two things. We modified the integration front ends and we added the user configuration options. And we also modified the web server modules to auto-detect whether the app is auto-supported or generic, and to pass the necessary information to the core controller. So now we have to modify the core controller to either process the info from the web server, or in case of Passenger standalone with the built-in engine, we need to perform our own auto-detection similar to what happened in the web server. And then when that is done, we need to pass the info to the application pool. So let's go ahead and do that. We need to go to the core, and the core controller is inside this directory, agent core controller. And it is split into multiple files that represent each of the stages in the controller. It starts with init request. So whenever the controller receives a request, the request starts in a function in this file. Let's see, which function do I need again? Oh, yeah, it begins with on request begin. Actually, let me show you what happens in this file so that you can follow how to navigate through the controller source code, because it's rather big. It begins here and it says, so first we perform some analysis on the request headers. We take a look at a couple of flag headers, and then we set a bunch of fields in there. And we take note of some of those things because we need them later. And then we try to initialize a bunch of stuff. We try to initialize some I/O objects. We try to initialize the response cache, which is called the turbo cache. We initialize the pool options object. And then when we're done with that, if the request has no body, or if request buffering is turned off by one of the flags in the headers, then the controller will proceed to call the application pool and try to obtain a process session from there. So it asks the application pool, give me an address that I can forward the request to. That's what checkout session does. And otherwise, it will begin with buffering the body. And then only after buffering the body will it proceed with calling checkout session. Okay, but what we're actually interested in is this thing, initialize pool options, because we need to ensure that the pool options object that is needed when calling the application pool contains the proper information that was passed from the web server. So let's follow this function call, and so there's a bunch of caching going on here. This branch is related to the single app mode, as you can see, but let's not do that yet. Let's take a look at what happens here. So there's a pool options cache object, and we try to look up an object from that cache with a key equal to the app group name. And the app group name is a value that is specified by the web server in the passenger app group name header. And all the code before here is just for looking up the value of the app group name header. And as we can see here, that if an options object has been retrieved from the cache, then we use that directly, and otherwise we create a new one. So the idea behind this caching is that most of the time all the related configuration that belongs to a certain application, most of the time they do not change. And when they do not change, we want to do less work for the sake of performance. But only if it is not already in cache, then do we want to try to parse all the configuration values that the web server sent us, and that happens in create new pool options. So here you see that it tries to create a new options object, and then it tries to look up all the headers in the request and try to do something with that. Okay, what do I need to edit here? Yeah, so here it tries to do something with the passenger app type header that was sent from the web server. But in the web server, we modify the code to not only send passenger app type, but sometimes to send passenger app start command instead. So we need to do something with that. If app type is not sent, then we try to do our own auto detection, which is related to single app mode. But actually now doing the auto detection immediately is not the right thing to do, because maybe the web server sent the app start command header. So let's try to look for that header. Yeah, remember that I told you that headers that begin with the bang tilde, then that passenger will reject them if they come from the client, and that only the web server is allowed to send these kinds of headers. That's why there is this secure headers thing. So the header parser in passenger makes sure that verifies that the request indeed came from the web server and not through a random HTTP client. And if so, then all these kind of headers are put in a separate hash table called secure headers. So we look up from there instead. And it is called passenger app start command. The secure headers lookup method, this hash table is of type serverkit header table, and serverkit is a framework in the passenger code base for writing high performance evented servers in C++. The header table here makes use of the L-string type, and I've introduced you before to the passenger static string type as well as the C++ standard library string type. So what is L-string? Well, L-string is a string type for representing a string that may be split into multiple discontiguous chunks. So when we receive data over a socket, we may not receive all the data we need in one go. Maybe we need 2 read calls from the socket in order to receive all the data. This is especially the case with when the client is slow. So for example, in one read call, we may receive let's say this, and then in another read call, we may receive the remaining value, something like this. And an L string is a sort of linked list structure that represents the fact that first we have this, but after that comes that. And we do this in order to implement a zero copy architecture inside Passenger, as well as for performance reasons. I mean, one of the ways to deal with the fact that we have discontiguous strings is to append them to a single string. But that would involve copying, and we want to avoid that. And so we invented the L string type in order to represent this natural structure that is in memory. And the header table type, the header table class, was specifically designed to be able to look up keys of type No, sorry, I did not say that correctly. It is specifically written to support values of type L-string. But so let's say that we try to look up the header and we found nothing, so it's not in the hash table, or maybe the header does exist, but for some reason the length is 0. Then in that case, we will want to fall back to the old behavior, so do our own auto detection here. And otherwise, we will want to say that we will want to set the application pool's option objects app start command field to the value that can be found inside the header. So as I said before, an L string may contain of multiple chunks, but most of the internal code in Passenger requires a single contiguous chunk of memory. How do we deal with that? Well, there's a helper function associated with L string that can, given a discontiguous L string, turn it into a contiguous L string. So that would involve a copy, but we only copy when it is necessary. And not all the time. And the fill pool options function contains code for calling that function to ensure that the string is contiguous. Okay, so we took care of this. But actually now I remember that the pool options object already has a field called start command. And this field was once introduced and it was reserved for future behavior, so this field is actually not used. And also this this header here, passenger start command, so instead of passenger app start command, this header was also never set. And since we're not using this anyway, let's reuse this. And just rename this field. Go to definition. Oh, I can't do that. Oh man, there are IntelliSense errors again. I'll fix that later. Okay, let's go to application pool. Options. Start command. Let's rename that to app start command. App start command. Yeah, we can skip this. Git app start command. Was this everything? Yeah, that was everything in this file. There's one more place in another file that uses this field directly, if I remember correctly. It's in group state inspection. So a group is a collection of processes that belong to the same app, and it is uniquely identified by the passenger app group name value. There is, oh man, IntelliSense is not working again. Inspect config in admin panel formats. Yeah, here we go. App start command. Okay, now we're done. Okay, so we modified the application pool And the application pool should pass the correct information to spawning kid. So at some point, the application pool will call spawning kid, telling it to spawn an application, but the spawning kid uses a different configuration object than the application pool itself. And the place where the place where the translation happens is here. In the spawning kid spawner class, there is a function setConfig from app pool options. And this is actually not a very good place because the spawning kid should not have a dependency on application pool. So this is actually a candidate for refactoring in the future. But for now, things are what it is, and we have to work with this. Yeah, remember that there is the auto-supported flow of spawning kit and there's a generic flow. We need to activate one of them depending on the application pool configuration or the application pool options. So if options.appType is empty, then activate the generic flow. And the start command here is equal to options.appStart command. And otherwise, we say generic app is false. Starts using wrapper is true. Start command is options.getStart command. Yeah, so basically this. Okay, one thing to notice, this here is a bug. Why? Because getStart command returns a C++ string object, but the start command field here in the spawning kit config object, let's see whether we can open that. Yeah, we can. It is a static string. So if we try to do an assignment here, and this is a mistake that happens regularly, what happens is that this function here returns a C++ string. The string data that the C++ string contains is assigned to the static string. And then the C++ string object is destroyed because we leave the scope, or actually because we leave the statement. And so the start command static string here will point to a dangling region of memory, an invalid region of memory that has been freed. And that's not good. What we actually want to happen is that if we assign start command here to the return value of this function, then we need to ensure that the return value here stays valid until we no longer need it. And there's an intern strings call here at the very end of this function that will ensure that all the string data that the config objects points through the static string fields are copied to an internal region so that they never get invalidated, and so that the lifetime of that string data is the same as the config object itself. But so we have to ensure that the string object that is returned here will live at least as long as will live until at least after we have called this function. And we can do that by assigning the return value here to a temporary object. And actually, this is a great place to put it. I see that in previously I had already taken care of this issue. So I remove this because we only need to call it in the else. we assign the return value to this temporary string object, and this string object is not destroyed until we leave the entire function, which is perfect. And then we assign the config start command field to the start command temporary variable. Okay, here we used to always set generic app is false. We no longer do that. We can get rid of these 2 lines. Also start single string wrapper. And we used to always set the start command here, but that's also no longer necessary. Okay. There is another place we need to modify. That's the user switching rules. So passenger tries to auto-detect what user an application belongs to and tries to start an application as that user by default. And the way we do that is by calling else-stat on the file on the so-called startup file. So each auto-supported application type that we support has a so-called startup file. For Ruby apps, it's config.ru. For Node.js apps, it's by default app.js, which is used by some frameworks, but it can be something else as well, depending on the user configuration. So some applications in other frameworks use index.js, and some other applications in yet other frameworks use a totally different file names. There isn't really a standard in the Node.js world. But Passenger basically needs to figure out what is the owner of that file, whatever that the user thinks that the startup file is. But in case of a generic app, we can't really, there is no such thing as a startup file. So we have to do something else. And I think that the right way to do that would be not to look at the owner of the startup file, but to look at the owner of the application root, because the application root always exists, whether it is an auto-supported app or a generic app. So let's start by renaming a few things. There's a startup file here, and we say if options.apptype is empty, so this is a generic app. Let's create a new variable called a reference file, and we want to figure out the owner of the reference file. Absolutize path options.approot, and otherwise we do this. The reference file equals equals the startup file. And then we rename this to reference file. So wherever we used to stat the startup file, we now stat the reference file instead. Okay. Startup file. Okay, there are 2 references. Oh, no, or actually there are 3 references. Okay, we call these reference file instead. Okay, looks like we're done with this function here. What else? Oh yeah, we need to ensure that that the application pool correctly shuts down a generic application process for the reasons I described earlier in the presentation. Because closing standard input is not enough to have a generic application shut down itself, so we need to send a signal. What file do I need? Oh yeah, process.h. The process class in the application pool subsystem represents a single application process. And there is a function here. I think it's trigger shutdown. Oh, IntelliSense. Or maybe it isn't. Okay, let's take a look at the input pipe. Oh yeah, it is the trigger shutdown function. So if there is an input pipe, then it closes that, but that's not enough. If the application type equals spawning kit results generic, so if this is a generic process, then we send it a signal. Sig term, okay. Now we're almost done. There is one last thing that we need to do, or actually not one last thing, but the one last important thing before we get to things like tests. It is we need to finish the single app mode that I talked about before. Where do I start? Yeah, let's start with the core config. So the config.h file inside the core defines all the configuration that the core accepts, that the core supports. And all this configuration is actually a composition of all the configuration supported by its subcomponents. We have a framework in the passenger code base called config kit, which allows us to define per component configuration, and it also allows easy composition of different components configurations together so that we don't have to write boilerplate code for passing high-level configuration to low-level components, which may exist in multiple layers in the component tree. I mean, if you have written a React app, then surely you know the pain of trying to pass all sorts of configuration from higher level components to low level components, especially when the tree is deep. Well, config kit in Passenger sort of solves that problem as well. But uses that through a very different way than, say, React context or something like, what was that name? What's that called again? Redux. Redux is the name. Yeah, the config kit in Passenger is more like a big hash table that supports schema validations. Let's see what I need to edit here. You know what? Let's start with a different component instead. Maybe this one is too high. So the core controller can also has configuration, and it can also be set to single app mode. And I believe that's where it comes from. I mean, that's where most of the configuration for single app modes comes from, because there is a controller single app mode schema that represents that configuration. Yeah, let's modify this instead. We want to add a new configuration option here called app start command, and it is of the string type, and let's say that this is optional and read-only. I used to have these two options here also marked as required, but let's mark them as optional now, because we want either these two to be given or this one, but not all three at the same time, but also not none of them at the same time. So we want to add a validator that validates the constraints that I described just now. Validate app type or app start command set. Okay. It accepts a config kit store. Oh yeah, you may be wondering, why do I call this here app start command? Because earlier we modified the option parser, and the option parser sets single app mode app start command. So why is there a difference? Well, that's because of the passenger philosophy of having multiple components in multiple layers and having the low level components be as specific as possible. So what we're looking at here is the configuration schema for the controller. And well, the controller actually has multiple schemas. It has a normal configuration schema, and it has a single app mode specific configuration schema. So as part of the composition process, config kit allows us to say that allows us to specify something like that low-level components have a specific name, but high-level components can have a different name for the same configuration option that configures a part of a component. Because depending on where in the abstraction level you are, you may want configuration options to have a different name. That concept is called translation. So right now we're working on the lowest layer, at least when it comes to the single app mode concept. So we're going to call this just app start command here, but one level higher in the core, we will add a translation there so that single app mode app start command is translated to app start command inside the controller. Yeah, let's work on the validation here. We want to set an alias here so that we don't end up having to type so much. If config app type is null and app start command is also null, then we want to add an error object to the error result array, saying either app type or app start command must be set. Okay, so what you're looking at here is you see these brackets here. That's because they indicate a specific configuration field name in the config kit schema. And config kit also has this neat feature where it translates the error messages from a low-level component to the corresponding field names in higher level components. So even though here we in the error message we say app type and app start command, if a high level component receives this error, then config kit can translate this app start command name here to single app mode app start command. So that in low level components we don't have to worry at all about how those names are called in high level components. We also want to check that if app type is set, but the startup file is not, then we define an error and we say if app type is set, then startup file must also be set. What else do we need to modify? Normalize. Yeah, okay. ConfigKit also has the concept of normalizers, which can do things such as ensuring that path configuration options that those paths are absolutized before the configuration values are accepted. That happens in normalizer functions. But there's the thing that all normalizer functions are always called, and the startup file option here may not be set because we made it optional now. So we have to check for that. If effective values.isMember startup file, then do whatever it is that you did. And otherwise don't do anything. Okay, now that we defined the low-level configuration, let's go back to the core and ensure that the composition happens properly. What do I need to modify? So inside the core schema, there is a place where I try to compose the single app mode controller subschema. And this composition here is a little bit weird and different than normal ones, so we need to add some boilerplate code here for taking care of the weirdness, because this is not how you usually do composition, but due to various complexities, we are forced to do this. But it's kind of difficult to explain in this in this screencast, so I'll skip the explanation and just show you what I need to do. Okay, all these are optional. What else do I need to do? I think we need to modify this one. Single app mode. These. Oh yeah, not only these two are also detected, but the single app mode app start command is also detected. Detected in initialize single app mode, so no need to validate them. Okay, we added a little bit of clarity. And there's a validator here called validate multi-app mode, which checks for the app type in the startup file. Oh yeah, we also need to check for the app start command. So we need to say that if we are in a multi-app mode, then none of the single app mode options are allowed. If multi-app mode is set, then single app mode app start command may not be set. Okay, I think we're done with this here. We should also modify the course main file because there's a function here that ensures that the single app mode that performs a kind of check on the single app mode configuration. Let's see. There's an initialize single app mode function here that is called when we boot the core. Okay, so as I said before, the web server performs auto detection on what kind of app it is. And the initialize single app mode function in the core does that as well, but only for the passenger standalone with built-in engine mode. So what we did before was auto detecting whether we run the auto detector here, but only if the app type option was not set. And now we need to do something slightly different. So if app type is not set, let me think. Actually, let's do this. If app type is not set and app start command is also not set, then we want to print an error. So standard error. It is not allowed for both app type and app start command to be set at the same time. Exit 1. Okay, let's see. If app start command is set, then this means that this is a generic app. The config specified that this is a generic app, and so we let's set a temp variable here. We need to define it. App start command is whatever is given from the configuration. String. And otherwise, so this was the old code path. Auto detect whether this is a generic app or auto supported app. Let's rename this variable to detector result in order to make this a little bit more readable, because this is just a temporary result and we're not going to return it, so we shouldn't call it result. What should we do? Well, actually, let's ignore the code block down here and let's try something else. if detector results dot app start command is empty, so if it has been detected as a an auto supported app, no, if it has been if it has been detected as a generic app, this is a generic app, then we set app start command is detector results dot app start command, and otherwise this is an auto supported app, and we can move the old code in here. In any case, we set the app type to the detector result.rubber registry. Yeah, actually, I'll just move that code here. Okay, I believe this is it. And here we can say this is an auto supported app. So here we checked for the app start command option. Here we checked whether app type is set or is not set, I mean. And if it is not set, then we try to also detect it either as a generic or an auto supported app. And otherwise, if app type is explicitly set, then it is still an auto-supported app, but in that case we do not need to auto-detect anything because the user specified what kind of auto-detected app it is, or auto-supported app it is. Okay, so far so good. And there's a code block here which, if the startup file configuration is set, then or is not set, then it will try to use the default that is associated to this application type, and otherwise it will try to take it from the config. Okay, I see what the code is doing here. Given a startup file, which is either passed through the configuration option by the user, or maybe it's the default startup file because the user hasn't passed a custom file name, it checks whether the file exists, and if it does not, then it prints an error. But we should only do this if this is not a generic app. And so here we put this entire code block in an if statement that checks whether the app type is not empty. Okay, then this here, yeah, this needs to be changed for the same reason. Let's see. If app type is not empty, then do this, otherwise do that. We will definitely want to print the app type here. And also, let's move these two lines to here. And otherwise, we will want to print app start command. Is this it? Well, I think we might have to modify the spaces here. Yeah, I need to add one more space here, here, and here. Okay. I think this is it. Yeah, as you can see, this latter part about modifying a single app mode, it's a bit weird, and the code is not all that clear. It's probably hard to follow, and this probably indicates that this part needs quite some refactorings. So that would be a to-do for the future. Now let's try to compile this and see what happens. Let's see whether this works. There is an error. In the core main, line 295. Okay, so this is detector result. Let's compile again. Oh, yeah, we have another typo in there. In init request.cpp, line 350, it's options. Okay, even though there is an error, the rake has not returned yet because there was another compiler that was running in the background. Okay, let's continue. Oh, and it's done. Okay, time to test this. Let's create a sample generic application and see whether it works. Let's create a temp folder in here and call it generic.test. So for the purpose of this of testing here, we're going to write a Node.js app, but we're not telling Passenger that it is a Node.js app. We're telling Passenger that it is a generic app and see whether that works. For the purpose of testing, it really doesn't matter in which language the app is written in. So let's give it a really non-conventional name. Let's say boots.js. And we create an HTTP server here. But let's require HTTP first. Yeah, and we will want to have it print something useful. So let's say we want to include the util module as well, so that we can print util.inspect the headers. The server is then HTTP create server given a function that accepts a request and response. We say response write header HTTP 200 with content type text plain, and we end it with this body util.inspect requested headers. Finally, let's say that we respect the port env, but it defaults on port 3000. So server.listen on that port, and we say console.log listening on this port. Okay, let's test the application by itself. Play is in play generic.test, and we started with node boot.js. So it says it's listening on port 3000. We open another terminal, and then we say we curl to port 3000, and then it should print the request headers. Yeah, there we go. Okay, so the application itself works. But does it work on Passenger? That's the question. So let's use Passenger standalone to test this, because Passenger standalone starts Passenger for Nginx under the hood, and then we'll end up testing two things at the same time. But before I do that, I need to compile my Nginx installation against the latest Passenger sources. So I had it right there. I already had an Nginx source directory here, which I use for development purposes, and it was already configured, so all I needed to do was run make and to have it compile against the latest Passenger object files. and I see that compilation had no errors, it had no warnings, and everything's fine. Well, there were some warnings, like there are these warnings, and I have no idea why I get these warnings, because I already cleared my object files several times and also cleared my C cache. As far as I know, my macOS command line tools installation is fine. So no idea why it prints this, and it only prints this for Nginx. But as far as I can tell, everything is fine. Okay, let's go back to the passenger source directory, and let's go back to the generic test application, and then we invoke passenger standalone. So I already modified my path to ensure that the passenger command inside the passenger source directory can be invoked. So we're invoking the correct passenger standalone. And we say passenger start, app start command is node boot.js, because that's how you normally start the app. And let's hope that this works. Yes, I want to allow Nginx. Okay, we can ignore this. This is one of those weird macOS error messages that that you regularly get from High Sierra, but they are actually harmless. So we can ignore this. And I want to fix this one of these days, but so far I haven't figured out where they come from. So it says listening on port 5000. 5000 is the port that passenger found that is free. And if we curl to port 5000, then we see that we can access the application directly, but we can also curl to port 3000, which is where passenger is listening on. And let's see what it says. See, it works. And you see that passenger added a few more headers. It said X forwarded for this IP address, and passenger also set the additional header passenger client address to this. So let's run passenger status. Yep, it works. It's on this PID. Let's double check in PS. Oh, oops. Yeah, I'm used to using iTerm, where just selecting something will result in a copy, but it doesn't happen in Visual Studio Code. Okay. And we can see that, yeah, that is indeed the Node.js process. So here you go. Generic language support works. Hey, thanks everyone for watching this session. I hope you have learned a lot. If things have gone a bit too fast for you, don't worry. A recording will be posted later. Keep an eye on our blog for announcements. If you have a question about the coding session, please leave a comment in this YouTube thread. And please like us on GitHub or join the discussion about Passenger 6 there. We are eager to hear your feedback. For example, how could generic language support benefit you? How could we change Passenger to address your use cases for today and tomorrow? My name is Hongli Lai. I'm CTO at Fusion. Let's talk.